Well, welcome to the first talk of today's event. I will be talking about emulating CI CD pipelines in LocalStack. This is the most recently added feature or rather set of services. It's something that we've been working for the past couple of months, and it lets you emulate the CI CD services in AWS. Like I said before, my name is Viren Nadkarni. I'm a senior software engineer at LocalStack. And I was part of the team which built these CI CD services. Apart from that, on the side, I maintain a bunch of other services like DynamoDB, EC2, Kinesis Analytics, among others. If you're not familiar with CI CD, it stands for continuous integration and continuous delivery. The core principle behind this philosophy is these two specific things. Continuous integration, which means that small changes are merged to the master branch on a very frequent basis, and continuous delivery, which involves releasing software in short cycles and at a very high frequency. In the past, we used to have systems like the waterfall model, which had a very linear structure. The requirements were decided first, and then happened the implementation, and then the delivery, and that was it. There was no provision for feedbacks. The CI CD system, the CI CD set of philosophies incorporates these things. And the core focus is automating this whole process. The first, one of the steps is building your software, which might involve compiling the software or building a package, and then testing it out, running all of the various test suites, unit tests, integration tests, end-to-end tests, and so on. And then ultimately releasing it, which could be either by publishing the package or the software, or deploying it by provisioning the infrastructure. AWS markets these set of tools in their developer tools category. Today, our focus is to focus on 5 of these services: CodeBuild, CodeDeploy, CodePipeline, CodeArtifact, and Code Connections. There's a bunch of other services in this same category, but they're out of the scope of today's talk. They're Code Commit, Code Guru. Some of these services have been deprecated, others have been renamed, but we're not going to talk about that today. Let's start with CodeBuild. CodeBuild is the build service on AWS. If you think of Docker build, when you're building an image using Docker, you specify a series of commands which are run in sequence, and ultimately you get an output, the artifact, which is the Docker image. CodeBuild works in a similar manner. There's this file called the build spec, where one specifies the list of commands which need to be executed in order for the build to finish running. And all of this happens in an isolated environment. It's basically a container. You can configure the environment in which these commands run, like the pre-installed software, if you have any need for libraries or compilers and so on. You can choose the operating system. By default, it's Linux, but you can also select Windows or Mac if your software requires it. And of course, you can also customize the resources that are available to you, the compute resources like the CPU, the memory, whether you need a GPU or not. And most of the time, a CodeBuild project produces output artifacts. That's why you need the CodeBuild project for. There's a bunch of other functionality that CodeBuild also provides, like caching to speed up your execution, you can specify the retries. If a certain command fails, you can choose to retry the whole project, reporting, and so on. Now, CodeDeploy is the deployment service. It has a very tight integration with other AWS services which run web services like EC2 or ECS or Lambda. And this tight integration lets it provide features like the ability to use various deployment strategies. you could perhaps choose to select blue-green deployments, which helps you. The core goal is to help you with fallbacks and reverts. If you realize after deploying that the software is faulty, you can instantly roll back to the previous version. CodeDeploy uses a specification called AppSpec, and the specifics of AppSpec varies depending on what the target service is. EC2, for example, has something called lifecycle hooks, where you can set what happens when certain events happen in the lifecycle. In similar manner, Lambda has validation tests, which let it identify that the Lambda function itself is running, and so on. Now, CodePipeline is the core service of this whole CI CD ecosystem on AWS. It handles the pipeline orchestration. And pipeline themselves, they are the core construct in the CI CD principles. It's specified as an acyclic directional graph. And the steps in the continuous execution, integration and testing are specified, are built into the design of the pipeline. Like you saw with CodeDeploy, CodePipeline has a very tight integration with other AWS services, S3, ECR, CodeBuild, and so on. We also have CodeArtifact. CodeArtifact is a service that lets you create package repositories. You could choose to have private repositories or public repositories, and it works very similar in a similar manner to JFrog Artifactory, if you're familiar with that. You can create registries for various types of programming languages. Say if you have a PyPy package that you need to publish, you could create a repository on CodeArtifact and publish it there without resorting to use the public PyPy registry. On AWS, there's support for a variety of these package repository types. Now, where does LocalStack stand in this ecosystem? In LocalStack v.5, which went out the beginning of this month, we've added emulation support for CodeBuild and CodePipeline, and we've added mock support for CodeDeploy and Code Connections. And up next, we are expecting to get CodeArtifact out. We've been working on adding mock support, as well as initial support for emulating NPM registries. So yeah, we're expecting to get it out, in this upcoming release of LocalStack. Right. So let's jump into the details. So the plan now is to understand build specs and pipeline declarations in a greater detail. We'll create a CodePipeline pipeline, which will fetch some source code from GitHub. It will compile the project and produce the binary, and then upload the binary to S3. And to make sure that the binary was compiled correctly, we'll download it to our system, and we'll try it out. All the source code that you'll be seeing now is available at this link over here. You can try it out later if you want. So for the specific project that we'll be working with, we'll be using this very nifty tool called FZF. It's a fuzzy finder, and I use it on a daily basis. I use it for its Vim integration. It's a Go project, and you can check it out at the link here. Now, let's take a look at what build specs look like. As I said before, build specs are YAML files. They are structured. It has a structure of consisting of various blocks, and each block serves a different purpose. Over here, the block that you see highlighted is the install blocks. In this block, you specify the runtime version that you want. The runtime version is basically the base image, the environment in which the commands run. Because we are dealing with a Go project, I've chosen Golang runtime environment with the 1.22 version of Golang. If your project uses a different programming language, you could choose a different one. Like there's support for .NET, Java, Ruby, Python, and you could also choose a different OS if that's your requirement. The next block, the next series of blocks determine the life cycle of the build process. There are three stages in a build. The first is the pre-build stage. In this stage, you set up the environment. Like if you have a need for additional libraries or additional compilers or additional software which is not provided by the runtime environment, you can do it here. For our case, I've just specified go-get. Go-get will fetch all of the dependent libraries of the project that we're trying to compile. The next stage is build, which is the central stage. This is where the core compute logic happens. And here we have go build, which will compile the core project for us. There's a third stage, post build, which is omitted in this example because we don't have a need for it. That stage is used for things like cleanups and just clearing up the environment. This block here, the artifact blocks, defines the output of the CodeBuild project. It informs CodeBuild that only a few set of files are important, and everything else has to be discarded. Like I said before, CodeBuild has a bunch of other features, retries, reporting. None of that is used in this example because we want to keep this as simple as possible. Just make it easy to understand. Now, what we saw explains how the project is built. But there's a bunch of other things that we need to do before we can even build the project. We still need to retrieve the source code. And after the project is built, we need to do something with the output, the FZF binary that was produced. That's where the pipeline comes into picture. By using a pipeline, you can organize the flow as set of as a well-organized system. Here you can see this sample pipeline that we're going to be working with, and the pipeline is divided into stages. Each stage, so here we have 3 stages: source, compile, and publish. And within each stage, there are actions. Code build, what I just explained, is an action, and that falls within the compile stage. You can have multiple actions in each stage. And when you have that, all stages execute in parallel. But again, CodePipeline is very flexible. You can also choose to execute certain actions before other actions in a given stage. Now, this pipeline that you see here will do, it will retrieve the source code from GitHub. I'll explain in detail how all that works. It passes that source code to CodeBuild. CodeBuild will use the build spec that we just saw to compile the project. And then the pipeline will upload the binary that is produced to S3. Now, the pipeline that we saw is described using the pipeline declaration. There are metadata fields at the very top, you have the metadata fields for version. This is a V1 type pipeline. There's the pipeline name. There's a role on field. Now, this is of particular importance. In AWS, everything, if a service can't access other resources unless explicitly permitted, and that's done using IAM, and the role has to have the proper permissions, and that role has to be assigned to the pipeline so that the pipeline can access these resources. Next, we have artifact store field. CodePipeline uses an S3 bucket as an intermediate storage. So the output of the first stage, the one to the left code connection, is placed in an S3 bucket. That's the artifact bucket before the code build stage can pick it up. That's where this section comes into picture. And all of this is followed by the stages, the stages that we're dealing with. We have 3 stages: source, compile, and publish. The first stage, source, just has one action. And in our case, we are using this service called Code Connection. Code Connection is this meta service in AWS. It deals with integration with other GitHub repositories. It also identifies triggers. So triggers are when the pipeline needs to be executed. You generally want the pipeline to be executed when a commit is made. But yeah, that's all of the other stuff. The important bits here in this piece of code is the repository ID that you can see at the bottom and the branch name. Pay attention to this branch name. So we are using version 0.62. This will be important later. The next stage is compile, where again, we just have one action. This is essentially the same thing that we saw earlier. It just runs the CodeBuild project and produces the binary. One important thing to notice is the input artifacts and output artifacts field. CodePipeline makes use of these values to determine how the artifacts flow between multiple stages. Here, the input artifact is source code, which happens to be the output artifact of the previous stage. And then we have the third stage, which is publish. In this stage, we just take the binary that was compiled by the previous stage and upload it to S3. Now, because we want this example to be very simple, we just publish it to S3. But you could perhaps use CodeDeploy to deploy your binary to wherever, if you're running on EC2, or you could use Code Artifact to publish the binary to a registry. Now, if you put all of the pieces together, this is how the pipeline actually looks. The code connections action retrieves the source code from GitHub. It puts it in the artifact bucket. Then the code build action retrieves the source code from the artifact bucket, does its thing, and then puts the output, which is the compiled binary, back to the artifact bucket. And then finally, the third action, S3 deploy, picks the compiled binary from the artifact bucket and uploads it to the output bucket. Okay, so let's jump into the demo. I have the LocalStack container running here in the background. And I'll be using AWS Local. AWS Local is a wrapper that we provide for AWS CLI. Just makes it easy for you to just use AWS, the entire AWS CLI with LocalStack. Now, the first step is to create the prerequisite resources. CodePipeline, pipelines do not create resources. When I say resources, I mean things like S3 buckets or even code build projects. All of this must exist beforehand. So let's start with code connections. I said earlier that code connections handles the connection with the GitHub repo, and that at the moment the service is mocked. So we just need to create this code connection. Next, let's create the IAM policies. IAM has roles. So we have this role here, which just grants CodePipeline the permission to assume role. And we have this policy here, which just gives it blanket access to S3 because the pipeline needs to publish to S3, the compiled binary, which is. We can create the role using IAM create role operation and pointing it to the role.json file that you just saw. And then associate the policy with the IAM role that we just created. Now, moving on to code build project, here's the build spec. It's the same build spec that you just saw in the slides. We have the Golang runtime. We have two stages here to get the dependencies and build the binary, and we specify the artifacts. The pipeline, the project can be created using CodeBuild create project operation. The project that we just created can be seen using this operation here, these projects. So most of the resources, prerequisite resources, apart from the buckets, are remaining now. So a quick reminder, we need to create two buckets. One is the artifact bucket, which is used as the intermediate storage, which we can create using this command here. And we also need to create the output bucket, which will hold the compiled binary, the action taken by the last stage. Oh, output bucket. Right. So next, let's create the pipeline. Here's the pipeline JSON. Now, this is the JSON representation of the YAML thing that we saw earlier. CodePipeline works with both YAML and JSON. It's essentially the same thing. It's just displayed differently. We have the exact same structure here. There's the metadata fields at the top. We have 3 stages, and in each stage we have the appropriate action. And we proceed to creating the pipeline using the create pipeline operation here. Right? So the pipeline has been created. And you will notice that all of this happens super fast. That's because LocalStack is running right here on my computer. AWS CLI does not need to contact AWS servers to create these resources. The pipeline that we just created can be seen in list pipelines operation here. And when I created the pipeline, LocalStack also started executing it. The executions of a pipeline can be seen using list pipeline executions. And you can see here that the pipeline, it produces a bunch of useful information. It obviously says the status, which is successful, it's good. And you can see other stuff like the trigger. It was a create pipeline which executed this pipeline. Okay, so the pipeline has been successful. We can now take a look at the output of the pipeline, which was the FZF binary. It should have compiled, it should have retrieved the source code from GitHub, should have compiled it, and it should have uploaded the binary to S3. We can get the binary using this command here. So just S3 copy. If I try to take a peek at what this file is using file, it tells me that it's an executable, which is good. And in order to try to run this binary, I need to first give it execute permissions. And if I run the version command, it's 0.62, which means that this is the one that we specified in the pipeline declaration. So that's great stuff. I can just now, we have the binary ready, and I could just use it as I would, yeah. So yes, that was a quick demo of how Codex services run in LocalStack. This was a very simple pipeline, and on a production system, we probably wouldn't have a pipeline as simple as this. LocalStack support for CodePipeline is pretty good. You can make this pipeline as sophisticated as you want. Say if you want to have another stage between source and compile stage where you want to run tests, you can do that. You could perhaps also want to, rather than uploading it to S3, you could publish it to CodeArtifact or deploy it to ECS. All of that is supported. Right, so that was it. LocalStack now has support for CI CD services, allowing you to design and test pipelines locally. You get all of the benefits that you get of having local emulation. the speed, the cost. And cost in particular is big here because AWS charges pipelines on a per pipeline basis, and each integrated service is charged separately. If you use CodeBuild, that is charged on a per minute basis on top of the cost of the pipeline. All of this adds up when you have a lot of pipelines. You'll obviously have a set of production pipelines and a set of developer pipelines, and that easily the cost easily adds up. LocalStack brings a relief in this area, giving you a cost relief at the same time, providing a cloud-like experience. That was all. Thank you very much, everyone, for listening. I know this was a very information-dense talk, but I hope you find this useful. All of these services are now available on LocalStack, so please try them out. If you need more features, say support for a new code pipeline action, please reach out to us by raising a feature request on GitHub.